Welcome to our exploration of Git and version control. Git is a powerful tool that serves as the backbone of modern software development. It allows multiple developers to work on the same project without stepping on each other's toes. By tracking every modification to the code in a repository, Git ensures that changes are clear and reversible. This capability not only prevents potential disasters but also facilitates a smoother workflow among team members. Understanding Git is crucial for anyone involved in software development. It's not just about keeping a backup of the code, it's about managing the evolution of a project. With Git, developers can revert to previous versions, compare changes over time, and merge updates from different branches. This level of control over the development process can significantly enhance productivity and reduce the risk of errors. The beauty of Git lies in its simplicity and power. Commands like and are integral to manipulating the project's history and structure. These commands help maintain the integrity and continuity of the development process. Moreover, Git's ability to handle large projects with speed and efficiency makes it an indispensable tool for developers. As we delve deeper into the world of Git, we'll explore how platforms like GitHub and GitLab build upon its foundational capabilities to enhance collaboration and streamline development workflows. These platforms are not just tools but ecosystems that foster innovation and efficiency in software development. Moving on to GitHub. GitHub takes the capabilities of Git and expands them into a vast social network for developers. At its core, GitHub is a web-based platform that hosts version control using Git. However, it's so much more than that. It facilitates collaboration across teams and the open-source community, making it easier for developers to share and manage projects. The platform's interface is user-friendly, allowing even those new to version control to navigate and utilize its features effectively. Developers can fork repositories, send pull requests, and manage changes with ease. This openness not only enhances individual projects but also contributes to the growth of global software development. GitHub also integrates various tools that improve the development process. Features like issue tracking, project boards, and wikis help teams organize and prioritize work. Moreover, GitHub Actions allows for automation of workflows from testing code to deploying applications. This integration of tools within a single platform simplifies the complexities of software development. Furthermore, GitHub's community features like discussions and contributions make it a hub for networking and learning. Developers can contribute to public projects, gaining exposure and experience in different aspects of software development. This community-driven approach helps in fostering innovation and sharing knowledge across the globe. Lastly, let's discuss GitLab. While GitHub focuses on collaboration and community, GitLab offers a more integrated approach to the entire software development lifecycle. GitLab is not only a platform for version control but also a comprehensive suite for continuous integration, CI, and continuous deployment, CD. This makes it an invaluable tool for DevOps practices, streamlining the process from code creation to deployment. GitLab's built-in CI/CD capabilities allow developers to automate their testing and deployment processes. This automation ensures that every piece of code is tested before it is deployed, reducing the chances of errors in the production environment. GitLab also provides detailed feedback on these processes, making it easier for teams to maintain high standards of code quality. Moreover, GitLab offers an issue tracker, a wiki, and a feature-rich API that integrates with many third-party tools. These features help teams collaborate more effectively and manage projects more efficiently. The platform's emphasis on automation and comprehensive toolset supports a more holistic approach to project management. GitLab also prioritizes security with features like built-in container scanning and static application security testing. These tools help identify vulnerabilities early in the development cycle, ensuring that security is a priority throughout the process. This focus on security is crucial for organizations dealing with sensitive information or large-scale applications. Section 4, GitHub versus GitLab, a comparative analysis. When comparing GitHub and GitLab, it's essential to understand that both platforms are built on the foundation of Git, but cater to slightly different needs and workflows. GitHub is renowned for its robust community features and user-friendly interface, making it ideal for collaborative projects and open-source initiatives. It's particularly favored by developers looking to contribute to public repositories or those who value a large network for collaboration. On the other hand, GitLab offers a more integrated solution that covers not just version control, but also project management and CI/CD. This makes it particularly attractive for teams that are looking to streamline their entire development lifecycle under a single platform. GitLab's emphasis on automation and comprehensive toolset is well suited for more complex or larger-scale projects. Both platforms offer high levels of security, extensive documentation, and support for various programming languages. However, the choice between GitHub and GitLab often comes down to specific project needs and team dynamics. For instance, a small team working on an open-source project might prefer GitHub for its community interactions, while a large enterprise requiring rigorous DevOps solutions might lean towards GitLab. Moreover, both platforms are continuously evolving. GitHub has recently enhanced its automation and integration capabilities, while GitLab continues to expand its security features and third-party integrations. This dynamic nature of both platforms means that they are continually adapting to the needs of the modern developer. Section 5. Conclusion: the importance of mastering Git, GitHub, and GitLab. Understanding Git, GitHub, and GitLab is essential for any developer or team involved in software development. These tools not only facilitate efficient version control but also enhance collaboration, streamline workflows, and ensure high standards of code quality. The ability to revert changes, track modifications, and automate deployments are just a few of the capabilities that make these tools indispensable. For individual developers, mastering these tools can significantly boost productivity and expand opportunities for collaboration and career growth. For teams, these platforms offer a way to manage complex projects with greater ease and reliability. The integration of project management, CI/CD, and security features, especially in platforms like GitLab, supports a more holistic approach to software development. Moreover, as the world of technology continues to evolve, the importance of these tools is only likely to increase. They are not just about managing code, but about fostering a culture of collaboration, efficiency, and continuous improvement. Whether you are a beginner looking to make your mark in the world of software development, or a seasoned professional aiming to optimize your workflows, mastering Git, GitHub, and GitLab is a crucial step forward. In conclusion, the journey of mastering these tools is not just about understanding technicalities, but embracing a mindset of innovation and collaboration. As developers and teams continue to leverage these platforms, the future of software development looks more promising and interconnected than ever. Imagine a digital vault, safeguarding every iteration of your project, ready to rewind to any past state. This is the power of a Git repository, a meticulous record keeper for your code. It captures snapshots of your project, enabling seamless navigation through its evolution. Forget the days of endless file copies, embrace the elegance of version control with Git. A Git repository is essentially a database tracking changes to your project files. It allows multiple developers to work concurrently on the same code base. This collaborative approach is central to modern software development, fostering efficiency and reducing errors. Understanding Git is no longer optional. It's a fundamental skill for any aspiring or experienced developer. Git's power extends beyond simple versioning. It provides tools for branching, merging, and resolving conflicts. These features are crucial for managing complex projects and supporting large development teams. Mastering these tools empowers developers to work independently on features, experiment with new ideas, and integrate their work seamlessly. Imagine a dedicated space on your computer, your personal coding haven where you can experiment freely without affecting the main project. This is your local Git repository. Every project you work on starts with a local repository, a safe environment to write, test, and refine your code. It's your personal sandbox before sharing changes with the team. Creating a local repository is simple. Navigate to your project directory and execute. This command creates a hidden directory, the heart of your repository. This directory tracks all modifications, acting as your project's changelog. It's important to remember that this repository is local, residing solely on your machine. Think of the local repository as your private workspace. You can make changes, experiment with new features, and even break the code. It happens, all without impacting others' work. This freedom is crucial for fostering creativity and encouraging exploration during development. Once you are satisfied with your changes, you can commit them to the local repository, taking a snapshot of your progress. While local repositories serve as your private workspace, remote repositories are the hubs for collaboration. They reside on a server, accessible to authorized team members. Think of them as the central repository for the project, where everyone synchronizes their work. Popular platforms for hosting remote repositories include GitHub, GitLab, and Bitbucket, each offering unique features for managing projects. Remote repositories unlock the power of teamwork. Developers can clone a remote repository to their local machines, creating a linked copy. This allows them to work on the project independently, pulling the latest changes from the remote and pushing their own contributions. This distributed workflow is the essence of modern collaborative development. Remote repositories offer more than just code storage. They provide a platform for issue tracking, feature requests, and code reviews. These collaborative tools streamline communication within development teams, fostering efficiency and transparency. Understanding how to effectively interact with remote repositories is essential for participating in collaborative software development. The real magic of Git unfolds when we connect our local repository, our personal sandbox, to a remote repository, the central hub. This connection bridges the gap, allowing us to share our code and collaborate with others. The two primary commands facilitating this connection are and creates a local copy of a remote repository on your machine, including its entire history and branches. This command is typically used when joining an existing project or starting work on a new feature. On the other hand, is used to connect an existing local repository to a remote one. This is useful if you started a project locally and now want to share it or collaborate with others. Once the connection is established, we can start exchanging changes between our local and remote repositories. Fetches changes from the remote repository and merges them into our local branch. This ensures that our local copy stays up to date with the latest codebase. Conversely, uploads our local commits to the remote repository, making our changes accessible to collaborators. Imagine working on a new feature for your project without affecting the main codebase. Git branches make this possible. A branch is essentially a parallel version of your code, allowing you to develop independently without modifying the main branch, often referred to as the main or master branch. Creating a new branch is as simple as executing. This creates a pointer to a specific commit, marking the starting point of your branch. To start working on the newly created branch use, this command switches your working directory to the specified branch, allowing you to make changes independently. Branches are invaluable for managing features, bug fixes, and experiments. They provide a safe and isolated environment to work on new code without disrupting the main development line. Once you've completed work on a branch and it's been thoroughly tested, it can be merged back into the main branch, integrating your changes into the main codebase. Once you've completed work on a branch, it's time to integrate those changes back into the main codebase. This process is called merging. Git provides a powerful command to seamlessly combine changes from different branches. Merging incorporates the commits from one branch into another, effectively combining the work done in parallel. The most common scenario is merging a feature branch back into the main branch. To do this, you would first switch to the main branch using and then execute. Git will then attempt to automatically merge the changes. If the changes don't overlap, the merge will be successful without any conflicts. However, if there are conflicting changes, Git will highlight these conflicts and require manual resolution. Conflicts occur when the same lines of code have been modified in different branches. Resolving conflicts involves choosing which changes to keep, modifying the affected code sections, and then committing the resolution. While conflicts can seem intimidating at first, Git provides tools and clear guidelines for resolving them effectively. Conflicts are an inevitable part of collaborative development. They occur when two or more developers modify the same lines of code in different branches. When these branches are merged, Git flags these discrepancies as conflicts, requiring manual intervention to decide which changes should prevail. While initially daunting, resolving conflicts is a manageable process with Git's guidance. Git provides clear visual cues within your code editor, highlighting the conflicting lines and the changes from each branch. You can choose to accept the changes from one branch to the other, or combine them manually. It's crucial to communicate with your team members when conflicts arise, discussing the best resolution to ensure code integrity. Once you've resolved the conflicting lines, you need to stage and commit the changes, just like any other modification. This commit acts as a record of the conflict resolution, preserving the decision-making process for future reference. Understanding how to resolve conflicts efficiently is essential for maintaining a smooth and collaborative development workflow. A well-maintained Git repository is a thing of beauty, a clear and concise history of your project's evolution. Achieving this clarity requires adhering to best practices, ensuring your repository remains a valuable asset, rather than a tangled mess. These practices involve clear commit messages, descriptive branch names, and a strategic approach to branching and merging. Start with meaningful commit messages. Each commit represents a snapshot of your project, and its message should clearly describe the changes made. A good commit message is concise yet descriptive, explaining what changed and why. Avoid vague messages like "fixed some bugs" and instead opt for specific descriptions like "fixed issue hash 123, improved error handling in user authentication." Next, adopt a clear branching strategy. Feature branches should be used for developing new functionalities, bug fix branches for addressing specific issues, and release branches for preparing stable versions of your software. This structured approach keeps your repository organized and makes it easier to track the progress of different development streams. Git's influence extends far beyond the realm of software development. Its robust version control system has found applications in diverse fields, from managing website content to collaborating on academic papers and even tracking changes in legal documents. This widespread adoption speaks volumes about Git's versatility and adaptability. Consider the world of web development. With Git, developers can seamlessly manage website updates, track changes to HTML, CSS, and JavaScript files, and revert to previous versions effortlessly. Platforms like GitHub have become the go-to platform for hosting website code, enabling easy deployment and collaboration among developers. In academia, researchers leverage Git to collaborate on papers, track changes, and maintain version history. This ensures everyone involved is working on the latest version, simplifying the process of co-authoring and peer review. Similarly, legal professionals are adopting Git to manage contracts, track amendments, and maintain a clear audit trail of modifications, improving transparency and accountability. Git truly shines when employed in a team setting. Its distributed nature empowers developers to work concurrently on different aspects of a project without impeding each other's progress. This parallel workflow, combined with robust branching and merging capabilities, makes Git an indispensable tool for collaborative software development. Effective communication is paramount when collaborating with Git. Regularly pulling changes from the remote repository ensures your local copy stays up to date, reducing the likelihood of merge conflicts. Clear and concise commit messages are crucial for informing teammates about the changes you've made. Code reviews are another essential aspect of team collaboration with Git. Before merging changes into the main branch, it's crucial to have other team members review the code, ensuring its quality and adherence to project standards. Platforms like GitHub and GitLab provide integrated tools for code review, facilitating seamless collaboration and knowledge sharing within development teams. In the ever-evolving landscape of software development, Git has emerged as an indispensable tool, a cornerstone of modern development practices. Its ability to track changes, manage versions, and facilitate collaboration has revolutionized the way software is designed, built, and deployed. Mastering Git is no longer optional. It's a fundamental skill for any aspiring or experienced developer. Embracing Git empowers developers to embrace a more efficient and collaborative workflow. The ability to experiment freely on branches, merge changes seamlessly, and track the entire history of a project fosters a culture of innovation and continuous improvement. Moreover, Git's widespread adoption ensures that developers can seamlessly transition between projects and teams, armed with a universal skill set. As you delve deeper into the world of Git, remember that its complexity is a reflection of its power. Don't be intimidated by the initial learning curve. Embrace the challenge and reap the rewards of mastering this essential tool. With dedication and practice, you'll unlock the full potential of Git, transforming your approach to software development and opening doors to endless possibilities.
In the world of software development, version control systems like Git are indispensable for managing code bases and facilitating collaboration. Two key concepts that empower developers to work effectively with Git are branches and tags. Imagine a tree where the main branch represents the stable version of your project, and smaller branches sprout off to accommodate new features, bug fixes, and experimental ideas. By creating branches, developers can work on specific tasks in isolation, making changes and experimenting freely. Tags act as bookmarks, marking specific points in the project's history, useful for denoting important milestones such as releases. The ability to manage different versions of a project concurrently through branches and tags is crucial for efficient software development. By understanding branches and tags, developers can streamline their workflow, improve collaboration, and deliver high-quality software. A branch in Git is a pointer to a specific commit in the project's history. When you create a new branch, you are creating a new path of development that diverges from the main branch. This new branch maintains its own commit history, allowing you to make changes without affecting the original branch. Branches are incredibly lightweight, making their creation and deletion quick and straightforward. By isolating changes within branches, you can ensure that the main branch always remains in a stable and deployable state. Once the feature is complete and thoroughly tested, you can merge the changes from your feature branch back into the main branch, integrating your work seamlessly. Various branching strategies have emerged to guide teams in effectively managing their codebase. One popular approach is the Gitflow workflow, which provides a robust framework for managing releases and hotfixes. In this model, the main branch represents the production-ready codebase, while a separate develop branch serves as the integration point for new features. Feature branches, branched off from develop, are used for developing individual features. Once a feature is complete, it is merged back into the develop branch for integration testing. When a release is due, a release branch is created from develop, allowing for final testing and bug fixes before merging into both main and develop branches. Another widely adopted strategy is the feature branch workflow, which emphasizes collaboration and code review. Before merging a feature branch into main, a pull request is created, initiating a code review process where other developers can provide feedback and ensure code quality. Adhering to best practices like using descriptive branch names, keeping branches short-lived, and regularly merging changes from the main branch into feature branches can greatly enhance the effectiveness of branching. Git provides a comprehensive set of commands for managing branches effectively. To create a new branch, use the command followed by the desired branch name. For instance, creates a new branch pointing to the current commit. To switch to a different branch, use the command followed by the branch name. For example, switches your working directory to the feature login branch. Any changes made from this point onward will be reflected only in this branch. Once you have completed your work on a branch and want to integrate it into another branch, use the command. This command merges the changes from the specified branch into the current branch. In cases where two branches have modified the same lines of code, merge conflicts may arise. Git handles these conflicts gracefully, highlighting the conflicting areas in the affected files. Deleting a branch after its integration is a common practice to keep the repository clean and organized. Understanding tags marking milestones in your project. Tags offer a mechanism to mark specific points in the project's history as being significant. These tags act as static pointers to specific commits, providing a way to record and easily revert to important milestones in the project's lifecycle. Unlike branches, which are mutable and can be updated with new commits, tags are immutable. Once a tag is created, it permanently points to the specific commit it was created on. This immutability makes tags ideal for marking release points, as they provide a reliable reference to the exact codebase that was released. Tags are often used to denote version numbers for releases. Creating a tag is as simple as executing the command followed by the desired tag name. To create a tag at a specific commit, you can append the commit hash to the command. Tagging best practices, ensuring clarity and reliability. Adopting a consistent and informative tag naming convention ensures that tags are self-explanatory and easily understandable by all team members. A widely adopted convention is to use semantic versioning for tags, where the tag name reflects the major, minor, and patch versions of the release. For instance, a tag name like v2 1.3 clearly indicates that this is the third patch release of the second minor release of the second major version of the software. Including a brief description with each tag can provide additional context about the tag. Git provides the option with the command to add a message to the tag. It's essential to ensure that tags are created on the correct branch and at the appropriate commit. Double-checking the branch and commit before creating a tag is always recommended. Pushing tags to the remote repository ensures that everyone is working with the same understanding of the project's release history. Branches versus forks. Choosing the right tool for the job. Branches and forks share some similarities in their ability to create separate lines of development, but they serve distinct purposes. Branches are lightweight pointers within a single repository that allow for parallel development and isolated experimentation. They are ideal for managing features, bug fixes, and other changes within the scope of a single project. Forks, on the other hand, are copies of an entire repository, including all its branches and history. Forks are particularly useful for experimenting with changes to a project without affecting the original codebase or contributing back to a project you don't have write access to. Choosing between branches and forks depends on the specific context and goals of your development workflow. Collaboration and efficiency, leveraging branches and tags for teamwork. In collaborative software development environments, effective communication and coordination are paramount. Branches and tags play a pivotal role in fostering seamless collaboration and streamlining the development workflow. By establishing clear branching strategies and conventions, teams can ensure that everyone is on the same page regarding how code is organized and integrated. Feature branches allow developers to work on specific features in isolation, minimizing the risk of code conflicts. Tags, with their ability to mark specific points in the project's history, provide a common reference point for all team members. The ability to easily revert to previous tagged releases also simplifies the process of rolling back changes if a critical bug is discovered in production. Real-world scenarios, applying branching and tagging to different projects. The concepts of branches and tags are highly versatile and can be applied to a wide range of software development projects. Imagine a team of developers working on a mobile application. They could use feature branches to isolate the development of new features, such as a new user interface or a payment integration module. Each feature branch would allow developers to work independently without affecting the main codebase. For a web development project, a team could utilize a branching strategy like Gitflow to manage releases and hotfixes effectively. The main branch would represent the live website, while a separate development branch would serve as the integration point for new features and bug fixes. Tags would be used to mark specific releases, allowing the team to easily roll back to previous versions if needed. In the context of open-source projects, forks play a crucial role in enabling contributions from external developers. Conclusion: the importance of mastering branches and tags. Mastering the concepts of branches and tags is essential for any developer seeking to harness the full potential of version control systems like Git. Branches, with their lightweight nature and ease of creation, encourage a modular and iterative approach to development. Tags provide a reliable mechanism for marking specific points in the project's history. By embracing best practices for branching and tagging, teams can establish a streamlined and efficient workflow that promotes code quality. Branches and tags are indispensable tools in the modern software developer's arsenal. By investing the time and effort to master these concepts, developers can significantly enhance their productivity and contribute to the success of their projects.
In the realm of Git, mastering the art of moving changes seamlessly between repositories and collaborators is paramount. While cloning and pushing changes are the conventional methods, there are situations where these approaches may not be feasible or ideal. Enter Git patches and bundles, two powerful tools that empower developers to exchange modifications effectively, even in offline or restricted network environments. Git patches provide a lightweight and portable format for sharing individual commits or a series of changes. Imagine them as recipes that encapsulate modifications made to a code base. These recipes, stored as plain text files, can then be applied to another repository, effectively replicating the changes. On the other hand, Git bundles offer a more comprehensive solution for packaging and transferring entire branches, or even a repository's history. This comprehensive guide delves deep into the intricacies of Git patches and bundles, equipping you with the knowledge to leverage these tools effectively in your workflow. From creating and applying patches to crafting and examining bundles, we'll explore the nuances of these techniques, empowering you to navigate diverse collaboration scenarios. Whether you're a seasoned Git user or just starting your journey, understanding patches and bundles will undoubtedly enhance your version control prowess. So, buckle up as we unravel the power of these essential Git functionalities. At its core, a Git patch is a text file that encapsulates changes made to a set of files. It's essentially a snapshot of the difference between two states of your codebase. Think of it as a set of instructions that tell Git how to transform one version of your files into another. These patches are created using the git diff command, which meticulously compares 2 points in your Git history and outputs the differences in a unified diff format. This format is universally recognized and can be interpreted by various tools, making patches highly portable and shareable. Each patch file contains not only the changes themselves, but also metadata about the commit they represent. This metadata includes the author's name and email, the timestamp of the commit, and the commit message, providing context and traceability to the modifications. The beauty of Git patches lies in their simplicity and flexibility. They can be easily shared via email, pasted into issue trackers, or even stored in version control systems themselves. Creating a Git patch is a straightforward process, typically involving just a few simple commands. The first step is to navigate to your Git repository and ensure you're on the branch containing the changes you want to encapsulate in the patch. Next, you'll use the git diff command, specifying the range of commits you want to include in the patch. If you want to create a patch for a single commit, you can reference that commit by its hash. For example, to create a patch for the commit with the hash abcdef, you would run the command git diff abcdef circumflex mypatch.patch. To create a patch for a range of commits, you can use the double dot notation. For instance, git diff commit1 commit2. mypatch patch would generate a patch containing the changes between commit1 and commit2. Once you execute the command, Git will generate a patch file named mypatch.patch in your current directory. This file contains the unified diff output, representing the changes made within the specified commit range. You can then share this patch file with collaborators or use it to apply the changes to another repository. Now that you have a Git patch, let's explore how to apply these changes to a code base. This process involves taking the modifications stored in the patch file and integrating them into your current branch. The primary tool for applying patches is the git apply command. You can apply a patch by navigating to the directory where the patch file is located and running git apply. For example, to apply the patch file named mypatch.patch, you would execute git apply mypatch.patch. Git will attempt to apply the changes described in the patch to your working directory. If the patch applies cleanly, meaning there are no conflicts with your existing code, the changes will be staged, ready for you to commit. However, if conflicts arise, Git will inform you and mark the conflicting areas in the affected files. You'll need to resolve these conflicts manually, similar to resolving merge conflicts. Once resolved, you can stage the changes and commit them. Section 5. Patching scenarios beyond the basics. Beyond the fundamental process of creating and applying patches, Git offers a range of options to refine your patching workflow. These options provide flexibility and control, allowing you to handle various scenarios effectively. For instance, the warstat option of git diff generates a condensed summary of the changes, showing the files modified and the number of lines added or removed. This is useful for getting a quick overview of the patch's contents before applying it. When applying a patch, You can use the P option to strip leading directories from file paths. This is particularly handy when dealing with patches generated in environments with different directory structures. Furthermore, the check option of Git apply allows you to perform a dry run without actually applying the patch. This is invaluable for verifying whether a patch will apply cleanly before making any modifications to your codebase. Mastering these advanced patching techniques empowers you to handle complex situations with ease, streamlining your collaboration and code management processes. Section 6. Diving into Git bundles. While patches excel at sharing individual commits or small sets of changes, Git bundles take center stage when you need to package and transfer larger units of work. These bundles are essentially archives that encapsulate the history of a branch or even an entire repository. Imagine you're working on a feature branch that spans multiple commits, and you want to share your progress with a colleague who doesn't have access to your remote repository. Instead of sending individual patches for each commit, you can create a single bundle containing the entire branch's history. This bundle can be transferred using any method such as email, USB drive, or a file sharing service. Your colleague can then clone the bundle, effectively replicating your branch on their local machine, complete with its commit history. Bundles are also incredibly useful for backing up repositories or migrating them between servers, especially in offline environments. They provide a self-contained snapshot of your project, ensuring data integrity and portability. Section 7. Crafting your first Git bundle. Creating a Git bundle is surprisingly straightforward. The Git bundle create command is your gateway to this functionality. To create a bundle, navigate to the repository you want to package and execute the command, followed by the desired bundle file name and the branch you want to include. For example, to create a bundle named MyBundle containing the feature branch, you would run git bundle create MyBundle feature branch. Git will then package the specified branch, including its entire commit history, into a single file named MyBundle. This file can be shared and used to recreate the branch on another machine. You can also create bundles that encompass the entire history of a repository using the all flag. For instance, git bundle create full repo bundle all would generate a bundle named full repo bundle containing all branches and tags. Receiving a Git bundle is like receiving a neatly wrapped package of code history. To unlock its contents and integrate them into your workflow, you can use the git clone and git fetch commands. To clone a bundle as if it were a regular repository, use git clone followed by the path to the bundle file. For instance, git clone path to MyBundle would create a new directory named MyBundle and clone the bundle's contents into it. If you want to fetch changes from a bundle into an existing repository, use git fetch instead. For example, git fetch path to MyBundle would download the bundle's contents, allowing you to then merge or cherry-pick changes from it. These commands provide flexibility in how you integrate bundle contents, allowing you to either create a fresh clone or incorporate changes into an existing project. Git bundles shine in various real-world scenarios, extending beyond the capabilities of traditional Git workflows. They prove particularly valuable in situations where direct repository access is restricted, or internet connectivity is unreliable. Imagine working on a project with sensitive code that cannot be hosted on public Git platforms. Bundles provide a secure way to share changes within a team, ensuring code confidentiality while maintaining a robust version control system. In scenarios where developers are geographically dispersed or working in areas with limited internet access, bundles facilitate offline collaboration. Developers can package their work, transfer it using physical media, and later integrate changes once connectivity is restored. Furthermore, bundles serve as excellent backup mechanisms. Regularly creating bundles of your repositories provides a safety net, protecting your valuable codebase from accidental data loss or corruption. While patches and bundles offer immense value, adhering to best practices ensures their effective and efficient use. Here are some guidelines to elevate your patching and bundling game. Use clear and concise names for your patch and bundle files, indicating their purpose or the changes they contain. When creating patches, aim for atomic commits, meaning each commit should encapsulate a single logical change. This makes patches easier to understand and apply. Before applying a patch, always review its contents using git diff or git apply. Check. to ensure it aligns with your expectations and won't introduce unintended changes. Be mindful of the sensitivity of the code you're bundling. If it contains proprietary or confidential information, ensure secure transfer mechanisms are in place. Integrate bundle creation into your backup strategy, regularly creating bundles of your important repositories to safeguard against data loss. Mastering Git patches and bundles unlocks a new level of proficiency in managing and sharing code. Patches provide a lightweight and versatile solution for exchanging individual commits or small change sets, while bundles excel at packaging and transferring entire branches or repository histories. By understanding the nuances of creating, applying, and managing patches and bundles, you gain the ability to navigate diverse collaboration scenarios, handle offline workflows, and implement robust backup strategies. Whether you're collaborating on open-source projects, working in restricted environments, or simply seeking to enhance your version control toolkit, embracing the power of patches and bundles will undoubtedly elevate your Git mastery. So go forth and wield these tools with confidence, streamlining your workflow and empowering seamless code collaboration.
In the world of software development, Git reigns supreme as the go-to version control system. Its power lies in its ability to track changes, manage different versions of code, and facilitate seamless collaboration among developers. Among the many powerful features Git offers, merging and rebasing stand out as essential tools for integrating code changes from different branches into a main code base. Mastering these operations is crucial for maintaining a clean and organized commit history, which is essential for efficient debugging, tracking progress, and collaborating effectively within a team. Conversely, a messy or convoluted history can lead to confusion, errors, and wasted time. By understanding the nuances of each operation, developers can make informed decisions about which approach is best suited for different scenarios, ultimately leading to a more streamlined and efficient development workflow. Git merge is a fundamental operation that allows developers to combine changes from one branch into another. It's the most common way to integrate changes from feature branches into the main development branch, often referred to as the main or master branch. The merge operation takes the contents of the source branch and integrates them into the target branch, creating a new merge commit that represents the combination of both branches. One of the key benefits of using Git merge is its non-destructive nature. When you perform a merge, Git preserves the entire history of both branches involved. This means that every commit from both the source and target branches remains intact and accessible, providing a comprehensive record of the project's development. If there are no conflicts, Git will create a new merge commit on the target branch, effectively integrating the changes from the source branch. Git rebase offers an alternative approach to integrating changes from one branch into another. Unlike merging, which preserves the history of both branches, rebasing rewrites the commit history by applying the commits from the source branch onto the target branch as if they were made directly on top of the target branch's latest commit. This results in a linear and streamlined commit history, often preferred for its clarity and ease of navigation. Rebases are particularly beneficial when working with feature branches that have diverged significantly from the main branch. By rebasing the feature branch onto the main branch before merging, you can avoid a messy merge commit and maintain a cleaner project history. However, it's crucial to understand that rebasing rewrites history, which can have implications when working with shared branches. Therefore, it's generally recommended to avoid rebasing public branches that others might have cloned or branched from. Both Git merge and rebase offer valuable approaches to integrating code changes, but they differ in their execution and resulting commit history. Choosing the right strategy depends on the specific context and the desired outcome. Merging is generally preferred when preserving the complete history of both branches is crucial, especially when working with public branches or collaborating with a large team. Rebases, on the other hand, excel at maintaining a clean and linear history, making them well suited for integrating private branches or working with smaller teams where history rewriting is less of a concern. When working with public branches or collaborating with a large team, merging is often the safer and more transparent approach. However, for private branches or smaller teams, rebasing can be a powerful tool for streamlining the commit history and simplifying the development process. In addition to merging and rebasing, Git provides another useful operation called squashing, which allows developers to combine multiple commits into a single commit. This can be particularly helpful when working on a feature branch where you might have made numerous small commits during the development process. Squashing these commits into a single commit before merging or rebasing can result in a more concise and meaningful history. Squashing commits is especially beneficial when you have a series of commits that are only relevant within the context of the feature branch. For example, you might have made several commits to fix a bug or refactor a specific piece of code. Squashing these commits into a single commit with a clear and descriptive message makes the history easier to understand and navigate. To squash commits, you can use the interactive rebase command, which allows you to select specific commits and choose how to combine them. When working on collaborative projects with shared branches, it's crucial to establish clear guidelines and best practices to avoid conflicts and maintain a healthy Git history. One fundamental rule is to avoid rebasing public branches that others might have cloned or branched from. Rebasing a public branch can lead to inconsistencies in the commit history, making it difficult for collaborators to synchronize their changes. Instead of rebasing public branches, consider using merging as the primary method for integrating changes. Merging preserves the complete history of both branches, ensuring that everyone's contributions are reflected in the main branch. Regularly pulling changes from the main branch and resolving conflicts promptly can also help prevent integration headaches. By staying in sync with the main branch and addressing conflicts as they arise, teams can ensure a smoother and more efficient development workflow. For developers seeking more granular control over their commit history, Git offers interactive rebasing. Interactive rebase allows you to reorder, edit, combine, or even delete commits during the rebasing process. This level of control can be incredibly powerful for cleaning up a messy history or preparing a branch for a pull request. To initiate an interactive rebase, you use the Git rebase, I command followed by the commit onto which you want to rebase. This will open an editor listing all the commits that will be rebased, along with instructions on how to manipulate them. You can then modify these instructions to perform various actions, such as reordering commits by changing their order in the list, squashing commits by changing the command from pick to squash, or editing commits by changing the command from pick to edit. Interactive rebase provides a flexible and powerful way to fine-tune your commit history, but it's important to use it with caution, especially when working with shared branches. While Git excels at merging changes, conflicts can arise when there are competing changes in the same lines of code, or when files have been renamed or deleted in one branch but modified in another. Merge conflicts are a common occurrence in software development, and understanding how to resolve them is crucial for a smooth workflow. When a merge conflict occurs, Git will pause the merge process and highlight the conflicting areas in the affected files. You'll then need to manually resolve these conflicts by choosing which changes to keep, which to discard, or by combining the changes from both branches. Once you've resolved all conflicts, you can stage the changes and continue with the merge process. Effective communication with team members can also be invaluable in understanding the context of the changes and finding the best resolution. Even with the best practices in place, mistakes can happen, and sometimes you might need to undo a merge or rebase. Fortunately, Git provides mechanisms for reverting changes and restoring your repository to a previous state. To undo a merge, you can use the git revert command followed by the hash of the merge commit you want to undo. This will create a new commit that undoes the changes introduced by the merge commit, effectively reverting the merge. However, it's important to note that reverting a merge doesn't delete the merge commit from the history. Reverting a rebase can be more complex, especially if the rebase involved rewriting a significant portion of the history. In some cases, you might be able to use git reflog to identify the commit before the rebase and then use git reset to restore the branch to that commit. Mastering Git operations, particularly merging and rebasing, is essential for any developer looking to enhance their version control workflow. Understanding the nuances of each operation, their respective use cases, and potential implications empowers developers to make informed decisions that align with their project's specific needs. While merging provides a safe and transparent approach for integrating changes, particularly in collaborative environments, rebasing offers a powerful way to maintain a clean and linear history, especially for private branches or smaller teams. By carefully considering the context and choosing the appropriate strategy, developers can streamline their workflow, minimize conflicts, and ensure a healthy and manageable Git history. By embracing the diverse capabilities of Git and adopting best practices for collaboration and version control, developers can unlock the full potential of this powerful tool and elevate their development process to new heights.
In today's fast-paced world of software development, having a reliable version control system is essential. Version control systems like Git act as a safety net for your codebase, allowing you to track changes, revert to previous versions, and collaborate seamlessly with other developers. Git has emerged as the de facto standard for version control, powering millions of projects worldwide. Its distributed nature allows developers to work independently on their own copies of the codebase, while still being able to merge their changes seamlessly. This distributed approach not only enhances collaboration but also provides resilience against data loss. The beauty of Git lies in its ability to capture snapshots of your project at different points in time, creating a detailed history of your code's evolution. With Git, you can easily compare different versions of your code, identify the source of bugs, and revert to previous states if needed. Moreover, Git's branching model empowers developers to experiment with new features or bug fixes in isolation without affecting the main code base. Branches act as separate lines of development, allowing you to explore different approaches and merge them back into the main branch only when they're ready. Among Git's powerful commands stands out as a versatile tool for moving specific commits between branches. Unlike merging, which brings in a whole branch's worth of changes, cherry-picking lets you pick individual commits to apply to your current branch. This precision makes invaluable in scenarios like backporting bug fixes or selectively applying features. Imagine you're working on a new feature in a separate branch, and a critical bug fix is implemented in the main branch. Instead of merging the entire main branch into your feature branch, you can use to pluck just the bug fix commit and apply it to your branch. This way, you get the bug fix without cluttering your feature branch with unrelated changes. It can also help maintain a clean and meaningful commit history. For instance, if you've accidentally committed a change to the wrong branch, you can use to apply that commit to the correct branch and then revert it from the original branch. This keeps your commit history accurate and reflects the true development process. Mastering involves understanding its syntax, potential pitfalls, and best practices. The basic syntax is straightforward. Before cherry-picking, ensure you're on the correct branch using and review the commit history with. Double-check the commit hash to avoid applying the wrong changes. If the changes don't conflict with your existing code, the cherry-pick will be successful. If there are conflicts, Git will pause the process and prompt you to resolve them manually. Resolve conflicts by reviewing the conflicting code blocks and making necessary adjustments. Once resolved, stage the changes using and continue the process with. If you decide to abort, use to return your branch to its previous state. The versatility shines in various real-world scenarios. Imagine you discover a critical bug in production. You fixed it in a development branch, but merging the entire branch could introduce unwanted changes. Cherry-pick the bug fix commit to apply it directly to the main branch, ensuring a quick and isolated fix. Break large features into smaller commits for better code review and testing. Use to selectively integrate specific commits from a feature branch into the main branch. If you accidentally commit to the wrong branch, used to apply the commit to the correct branch and revert it from the original branch. Create a separate branch for experiments and cherry-pick relevant commits to see how they work in your main project. This approach ensures that only essential changes are introduced, simplifying conflict resolution. Cherry-picking can also be beneficial when dealing with bugs that span multiple branches. Apply the specific commit containing the fix to all affected branches, ensuring consistency and reducing the risk of introducing inconsistencies. A clean and well-maintained Git history is crucial for collaboration, debugging, and overall project health. Can help prevent unnecessary merge commits, resulting in a more linear and understandable history. By cherry-picking individual commits, you can incorporate specific changes without introducing extraneous merge commits. This keeps your history clear and logical. Cherry-picking also helps avoid merge conflicts by incrementally integrating smaller, self-contained changes from feature branches into the main branch. This ensures that your main branch remains stable and deployable. In today's agile software development landscape, continuous integration and continuous delivery (CI/CD) are indispensable. CI/CD pipelines automate building, testing, and deploying code changes, enabling faster and more reliable software delivery. Plays a crucial role in optimizing CI/CD workflows. It facilitates hotfix deployments by isolating specific commits containing fixes and deploying them directly to production. This minimizes downtime and ensures a rapid response to critical issues. Cherry-picking can also automate backporting bug fixes to older release branches, ensuring consistency across all supported versions. This approach streamlines feature rollouts by gradually introducing smaller, self-contained changes. Bug fixing is an integral part of software development and is a valuable asset in the bug-fixing arsenal. It enables developers to target specific commits and apply them strategically to address issues without unnecessary code bloat. When a bug is discovered, the fix is often contained within a single commit or a small set of commits. Instead of merging an entire branch, use to pinpoint the exact commits containing the fix and apply them directly to the affected branch. This approach ensures that only essential changes are introduced, simplifying conflict resolution. Cherry-picking is also beneficial when dealing with bugs that span multiple branches. Apply the specific commit containing the fix to all affected branches, ensuring consistency and reducing the risk of introducing inconsistencies. Feature branching allows developers to work on new features in isolation without affecting the main codebase. Integrating those branches back into the main codebase can be challenging. Offers a powerful alternative to traditional merging, providing greater control and flexibility in managing feature integration. It allows you to integrate specific commits rather than entire branches. This is useful when working on large features broken down into smaller commits. Incremental integration reduces the risk of merge conflicts and allows for earlier feedback and integration testing. It also provides greater flexibility in managing feature releases, used to streamline the process of backporting features to older release branches. While it's powerful, it's most effective when used correctly and strategically. Understand the context of the commit before cherry-picking. Review the commit message, examine the changes, and consider its dependencies. Cherry-pick individual commits rather than ranges to reduce conflicts. Thoroughly test your code after cherry-picking to ensure correct integration. Communicate with your team to avoid confusion and ensure everyone is aware of the changes. Establish a consistent workflow for cherry-picking commits. While it's powerful, it's not without potential pitfalls. Merge conflicts are common. Ensure you understand the changes and that the target branch is clean before cherry-picking. Cherry-picking isolates commits from their original context, which can lead to confusion. Review the commit message and consider dependencies before cherry-picking. Avoid duplicate commits by reviewing the commit history of the target branch. Cherry-picking commits that introduce breaking changes without proper testing can lead to instability. Assess the potential impact of a commit before cherry-picking. Use a consistent workflow to track cherry-pick commits. In modern software development, efficiency, precision, and a clean Git history are paramount. Empowers developers to navigate version control with finesse, enabling them to move commits between branches, streamline workflows, and maintain a pristine code base. From backporting bug fixes to selectively integrating features, cherry picking proves its mettle in various scenarios. Its ability to isolate and apply specific commits provides unparalleled control over code integration. Understanding its nuances and best practices is essential for harnessing its full potential. Embrace its power, master its intricacies, and watch your development workflow transform into a symphony of efficiency and elegance. Welcome to the first part of our deep dive into how developers can use Git cherry pick effectively. Pause 1s. Cherry pick is not just a tool, it's an art form that, when mastered, can significantly streamline your workflow and maintain code consistency across branches. Pause 1s. Let's start with the basics, identifying the right commits to cherry pick. Always ensure that the commit you are planning to cherry pick is isolated and does not depend on other changes that are not being cherry picked. This ensures that your cherry-picked commit does not introduce unexpected bugs or issues. Pause 1s. Next, consider the context of your commits. Understand the impact of the changes you are cherry-picking on the target branch. It's crucial to avoid conflicts and ensure that the commit aligns with the overall code base. Pause 1s. Now, let's get into a practical example. Imagine you have a feature branch with a crucial bug fix that needs to be applied to the main branch. By using Git cherry pick, you can isolate that specific commit and apply it directly to the main branch without merging the entire feature branch. Pause 1s. Open your terminal and navigate to the main branch. Use the git cherry pick command followed by the commit hash of the bug fix. This will apply the changes from that commit to your current branch. Pause 1s. Pause 1s. With this simple command, you can ensure that critical fixes are applied promptly and efficiently, maintaining the stability and integrity of your codebase. Pause 1s. In the next part, we will delve deeper into more advanced cherry-picking techniques and scenarios. Stay tuned to unlock the full potential of Git cherry pick in your development workflow. Pause 1s. Until then, keep experimenting and refining your cherry-picking skills. The more you practice, the more proficient you will become in leveraging this powerful Git command. Pause 1s. Thank you for watching, and don't forget to like, share, and subscribe for more insightful content on mastering Git and other development tools. Pause 1s. See you in the next chapter. Welcome back to the second part of our deep dive into mastering Git cherry pick. Pause 1s. In this chapter, we will explore advanced techniques and scenarios where cherry pick can truly be a game changer in your development workflow. Pause 1s. First, let's talk about conflict resolution. When cherry-picking a commit, conflicts can arise if the target branch has changes that overlap with the commit being applied. To resolve these conflicts, use the git merge tool or manually edit the files to reconcile differences. After resolving conflicts, use git cherry pick. Continue to complete the process. Pause 1s. Next, managing dependencies is crucial. Sometimes a commit you want to cherry pick relies on other commits. In such cases, it's essential to cherry-pick the dependent commits first to maintain the integrity of your codebase. You can identify these dependencies using git log or git blame commands to trace the history and relationships between commits. Pause 1s. Maintaining a clean commit history is another important aspect. Cherry-picking allows you to selectively apply changes without merging entire branches, which helps in keeping your commit history clean and focused. Use Git rebase to interactively rebase and squash commits if necessary, ensuring that your history remains tidy and easy to understand. Pause 1s. Now let's consider a practical example. Suppose you have a hotfix on a release branch that needs to be applied to the development branch. By cherry-picking the hotfix commit, you can ensure that the fix is propagated without merging unrelated changes from the release branch. This targeted approach helps maintain stability and consistency across branches. Pause 1s. Open your terminal and switch to the development branch. Use the git cherry pick command followed by the commit hash of the hotfix. If conflicts arise, resolve them as discussed earlier and continue the cherry pick process. This method ensures that critical updates are seamlessly integrated into your development workflow. Pause 1s. In the next chapter, we will explore even more advanced scenarios and best practices for using Git cherry pick effectively. Stay tuned to elevate your Git skills to the next level. Pause 1s. Thank you for watching, and don't forget to like, share, and subscribe for more insightful content on mastering Git and other development tools. See you in the next chapter. In today's fast-paced software development world, speed, agility, and reliability are paramount. To stay competitive, teams must embrace practices that streamline workflows, enhance collaboration, and ensure code quality. This is where continuous integration, or CI, comes into play, and at the heart of effective CI lies a powerful tool. Git, a distributed version control system, has become the industry standard for managing code bases. Its ability to track changes, facilitate collaboration, and enable seamless rollbacks has revolutionized the way software is developed. However, Git's true potential extends far beyond basic commits and pushes. To unlock the full power of CI, a deep dive into advanced Git techniques is essential. Let's dive in. Continuous integration is more than just a buzzword. It's a fundamental shift in how software is built and delivered. At its core, CI champions frequent code integrations, automated builds, and rigorous testing, all aimed at identifying and resolving issues early in the development cycle. This iterative approach minimizes integration problems, reduces the feedback loop, and ultimately leads to faster delivery of high-quality software. While basic Git knowledge is enough to get started with version control, truly harnessing the power of CI requires a deeper understanding of Git's capabilities. Advanced Git techniques, such as Git hooks, strategic branching models, and seamless integration with automation servers like Jenkins, are the key ingredients for building robust and efficient CI pipelines. Git hooks, for instance, act as automated scripts triggered by specific Git events such as commits or pushes. These hooks serve as gatekeepers, enforcing code quality standards, running automated tests, and even deploying code to staging environments without manual intervention. By embracing these advanced Git techniques, you unlock a new level of automation, efficiency, and reliability in your CI pipeline. Git hooks are a powerful feature that allows you to automate tasks within your Git workflow. These hooks are essentially scripts that are triggered by specific Git events, such as committing code, pushing changes, or receiving updates. By leveraging Git hooks, you can enforce code quality standards, automate tedious tasks, and ensure consistency across your project. One of the most common uses of Git hooks is to enforce code style guidelines. By configuring a pre-commit hook, you can automatically run a code linter before each commit. This ensures that all code committed to the repository adheres to the defined style guidelines, preventing messy code from being introduced. Another valuable application of Git hooks is to trigger automated tests. By setting up a pre-push hook, you can run your test suite automatically before any code is pushed to the remote repository. By incorporating Git hooks into your CI pipeline, you can significantly improve code quality, reduce manual errors, and streamline your development process. While client-side Git hooks offer significant automation and control over individual workflows, server-side hooks take these benefits to a team-wide level. These hooks reside on the server hosting your Git repository and are triggered by events like pushes, receives, or updates to references. They act as gatekeepers, enforcing policies and best practices across the entire team. One of the primary advantages of server-side hooks is their ability to enforce code quality standards consistently. By implementing a pre-receive hook on your Git server, you can automatically reject pushes that do not meet predefined code style guidelines or fail to pass automated tests. This ensures that only clean, well-formatted, and thoroughly tested code makes its way into the main code base. Furthermore, server-side hooks can be used to prevent accidental or unauthorized changes to critical branches. For instance, you can configure a hook to restrict direct pushes to the master branch, enforcing a pull request workflow for all code integrations. This adds an extra layer of control and ensures that all code changes are reviewed and approved before being merged into production-ready branches. However, it's crucial to use server-side hooks judiciously. Branching strategies are essential for managing code changes effectively in a team environment. A well-defined branching strategy provides a clear roadmap for developers, reduces merge conflicts, and ensures a streamlined workflow from development to production. Choosing the right branching strategy depends on various factors, including team size, project complexity, and release frequency. One of the most popular branching strategies is Git flow. Git flow is a robust model that utilizes multiple branches to represent different stages of development, including development, features, releases, and hotfixes. It's a comprehensive strategy that works well for large projects with dedicated release cycles. Another popular strategy is GitHub flow, a simpler and more streamlined approach that revolves around a single master branch representing the production-ready code. Developers create feature branches off of master, and once the feature is complete, they submit a pull request to merge their changes back into master. Selecting the right branching strategy requires careful consideration of your team's needs and workflows. Git flow is a widely adopted branching model known for its robust structure and suitability for large, complex projects with dedicated release cycles. This model utilizes several branches, each serving a specific purpose, to streamline the development process and ensure a clear separation of concerns. At the heart of Git flow lie two main branches, master and develop. The master branch represents the production-ready codebase containing the most stable version of your software. The develop branch, on the other hand, serves as the integration branch where all feature branches are merged. Feature branches are created from the develop branch and are dedicated to developing specific features or bug fixes. Once a feature is complete and tested, it's merged back into the develop branch. When it's time for a new release, a release branch is created from the develop branch. This branch is dedicated to final testing, bug fixing, and preparing the release candidate. Git flow's structured approach provides several benefits, including a clear separation of concerns, improved collaboration, and a streamlined release process. In contrast to Git flow's comprehensive structure, GitHub Flow offers a simpler and more streamlined approach to branching, making it ideal for smaller teams, projects with frequent releases, and continuous delivery workflows. This model centers around a single, always releasable master branch representing the production-ready codebase. Instead of utilizing separate branches for development, features, and releases, GitHub Flow advocates for creating feature branches directly from the master branch. Each feature branch is dedicated to a specific feature or bug fix, and is treated as a short-lived branch that is merged back into master as soon as it's complete and tested. Once a developer is ready to begin working on a new feature, they create a new branch from the master branch, giving the branch a descriptive name that reflects the feature being developed. This branch serves as an isolated environment where the developer can work on their changes without affecting the main codebase. When the feature is complete and all tests are passing, the developer submits a pull request, proposing to merge their changes from their feature branch back into the master branch. This pull request serves as a formal request for code review and integration. Jenkins, an open-source automation server, plays a pivotal role in establishing efficient and robust continuous integration pipelines. It empowers teams to automate various stages of the software development lifecycle, from building and testing to deploying and releasing software. Its flexibility, extensive plugin ecosystem, and active community make it a popular choice for organizations of all sizes. At its core, Jenkins acts as a central hub that orchestrates the execution of predefined jobs, each representing a specific task or stage in your CI pipeline. These jobs can be configured to run automatically based on various triggers, such as code commits, scheduled intervals, or the completion of other jobs. One of Jenkins's primary strengths lies in its vast plugin library. With thousands of plugins available, Jenkins can be easily integrated with a wide range of tools and technologies, including version control systems, build tools, testing frameworks, and deployment platforms. This extensive integration capability allows you to tailor Jenkins to fit your specific workflow and toolchain. Integrating Jenkins with your Git repository is paramount for achieving true continuous integration. This powerful combination allows for automatic triggering of builds, tests, and even deployments whenever code changes are pushed to your repository, streamlining the development process and ensuring that your software is always in a releasable state. One of the most common ways to integrate Jenkins with Git is by using the Git plugin. This plugin allows Jenkins to monitor your Git repository for changes and automatically trigger builds whenever new commits are pushed. You can configure the plugin to monitor specific branches, listen for specific commit messages, or even trigger builds based on the contents of the changes. Once Jenkins detects a change in your repository, it checks out the latest code and proceeds to execute the configured build steps. These steps might include compiling the code, running unit tests, performing static code analysis, or generating documentation. If all build steps are successful, Jenkins can automatically deploy the built artifacts to your desired environment. The integration between Jenkins and Git can be further enhanced by leveraging webhooks. Embracing advanced Git techniques and integrating them with a robust continuous integration pipeline brings forth a multitude of benefits, significantly enhancing the speed, reliability, and collaborative spirit of your software development process. One of the most tangible benefits is increased development speed. By automating tasks such as building, testing, and deploying code, CI frees up developers from tedious manual processes, allowing them to focus on what they do best: writing code. This automation also reduces the time it takes for code changes to reach production, enabling faster delivery of features and bug fixes. Another significant advantage is improved code quality and reliability. With automated testing integrated into the CI pipeline, bugs and regressions are caught early on, preventing them from reaching production and impacting end users. CI also fosters a more collaborative development environment. With frequent code integrations and automated builds, developers can work on features in parallel and integrate their changes seamlessly. This collaborative workflow minimizes integration issues, reduces merge conflicts, and promotes knowledge sharing among team members. While the benefits of advanced Git and continuous integration are undeniable, there are potential pitfalls that teams must be aware of and actively avoid to ensure a smooth and efficient development process. Two common challenges are merge conflicts and broken builds, both of which can disrupt the workflow and hinder productivity. Merge conflicts arise when two or more developers modify the same lines of code in their respective branches. These conflicts require manual resolution, which can be time-consuming and error-prone, especially as the team and codebase grow. To minimize merge conflicts, encourage frequent communication among team members, promote smaller and more focused branches, and leverage tools that visualize and assist with merge conflict resolution. Broken builds, where the automated build process fails due to code errors, configuration issues, or environmental problems, are another common pain point. Broken builds can halt the CI pipeline, delaying deployments and impacting the entire team. To prevent broken builds, ensure that your test suite is comprehensive and reliable, set up automated code quality checks, and establish clear communication channels to alert developers immediately when a build breaks. Another potential pitfall is the complexity of managing CI pipelines, especially as the project scales. To address this, strive for simplicity and modularity in your pipeline design, leverage configuration management tools, and implement robust monitoring and logging to quickly identify and resolve issues.